All right, I must have done 10 takes on this already. I've considered doing it live and ultimately just opted to pre-record it. What I'm really trying to get at in this video is probably what's on everybody's mind last few weeks or so, especially in certain areas of the US. Um, Drones, just probably what are just hobbyist drones. But anyways, uh, I wanted to show some recent work that I've done on a kit that I'm looking to offer up here soon, which is the WarDragon Pro. In this particular box that you see in the image here, what I'm trying to do is detect FAA type remote ID. It's also detectable in certain places in Europe. Appears to be about the same standard. I've got good results back from over there distance wise. What I'm trying to do here is create a early warning long distance detection capability for remote ID and other types of drone information. And not only can you detect that early, but you can use the host-based computer in order to run various different applications. One application in particular I've talked about and shown before is my DragonSync repository. That is a collection of Python scripts that can take the remote ID decoded information and convert it into cursory on target in order to send to ATAK, TAK server, whether it's unencrypted, encrypted. I mean, the communication between the box and the server is what I'm referring to. So it's pretty flexible in what it can do. And then if you hang with me in this video, I know it's going to seem like I'm jumping all over. I probably do that often. Just hang with me. We'll go through this, and what I want to show is a iOS application that Luke, an individual, is or has been putting together for me that you can see, and that's really what kind of took a while to get this video going, is just figuring out how to cast my iPhone screen to Linux. That is in the background off to the left hand side there. Give me a second and you will see that that app can connect to the WarDragon in order to get information, whether it's listening for cursory on target messages, multicast, I should say, much like ATAK, or it has the ability to go direct to what's called a ZMQ server or two that are running on the WarDragon that offers up information on both detected drones and the box itself. What do I mean by the box itself? Well, you can see on the right hand side over here there's a GPS. So what I have done is I have a ZMQ server that is hosting up information about the box, such as its temperature, RAM, CPU usage, GPS location, some other statistics that I hope to expand on. The dongle that's right underneath that on the right hand side, since I'm looking at this image, that is what is dedicated to detecting Bluetooth type remote ID. Particularly interested in the Bluetooth long range extended, which can be picked up from quite a distance away. There's an external antenna on the outside of the box that covers that, and I might as well point it out on the left hand side. Currently, there is a modified ESP32 that I have solely dedicated. I've kind of cut its CPU usage in half just because I really wanted to keep the temperature down and its usage down, and I have dedicated it to detecting the Wi-Fi type uh, drone ID, remote ID, sorry, and that has been picked up from distances up to 5-6 kilometers away with an external antenna. Now there was an LNA added in a particular test by somebody, but even without that, it's been able to detect various different DJI models of drones from kilometers away. Now, also, it gets a little confusing because there's the FAA remote ID, and then when you're talking about DJI, in the past you probably have seen me do videos where I was decoding the drone ID. So drone ID, I guess I would consider that more probably proprietary to DJI, along with their OcuSync and some of their protocols requires a rather robust SDR to look at a pretty significant chunk of bandwidth in order to decode that drone ID. That is still possible, and the ANTSDR is capable of doing that really well, loaded with a particular firmware that I've talked about in the past. That is partly why I have the ANTSDR in there, because if somebody chooses to use that firmware, there still could be that capability out there, although DJI, from what I understand, I don't know if it's all models or particularly which models, it has started to encrypt that DJI drone ID. And so while you can detect it, you can't necessarily decode it in order to see lat, long, pilot, operator, all that information. But you can do the same with what DJI is also having to put on the drone to comply with different regulations, the remote ID. So you pretty much can get the same information. Okay, and let me think what else. And so also the reason why I chose the ANTSDR is I have a very early build of it, and I don't want to get ahead of myself because I don't know any timelines of microphase or anything like that. But I have tested a firmware that allowed me to detect the video links of various different types of drones, which is really interesting because even though you might not get exact location data out of that, you do know that there's a drone, a certain type of video link in the area. Now, I suppose if you had several WarDragon boxes stationary, spaced out, and you were getting these hits from different boxes, well, you probably could do some math there and figure out roughly about where the drone is at based on maybe power, RISI levels, or something of that nature. Hoping to maybe get something that sophisticated in the near future. But for now, it seems to be doing pretty well with detecting Bluetooth remote ID and Wi-Fi remote ID, and then of course, depending on the firmware loaded, you can get the DJI drone ID, just to make this super confusing. Now I'm probably going to ship the WarDragon with the ANTSDR having a stock UHD firmware, and then probably a repository that you can grab different firmwares and change it out. The ANTSDR, of course, is going to raise the price quite a bit along with the other features and software that I've put on here versus the other ones. So that's, I mean, that's kind of covering what is in the box. Hopefully this isn't too boring with just me talking and you looking at the box, but I wanted to try and walk through this, especially for those people that are interested in a kit like this, in order to put around their property or whatever it may be, in order to detect things that are happening in the electromagnetic spectrum that they might not otherwise know about. And you might be like, well, what do I really care about a drone? Well, some people do. Some people might want to know, hey, there's a drone that has been flying over my property. I want to know the information about it. Who knows? Maybe somebody's checking out your area and are going to come back later or something. I don't know, but there's significant use cases for this, especially protecting different facilities and stuff. Now, I'm not kidding myself. If somebody really wants to do the wrong thing, they could probably disable remote ID or not comply and so on and so forth. And then maybe that's where other techniques such as detecting the video links will come in, or maybe visual techniques using computer vision or something like that. So anyways, that's what the box looks like. Let's see what it's kind of designed to do right out of the box, and I'll try and walk through that. What I have decided to do is I've decided to start 3 services when this box is purchased and it's kind of running behind the scenes. One, there's this WarDragon service, and what that's doing is that's looking at, like I said, the status of the box itself, offers up GPS location, serial number, temperature. It offers that up on a particular port, 4225 I believe it is. That's a ZMQ server that can be subscribed to. Matter of fact, you can see it on the iPhone app here, 4225. That's also what DragonSync connects to, and then sucks that information up that's in like a JSON format and converts it to cursor on target and multicast and all that. Okay. It also has status, the sniff receiver, which that is controlling the Bluetooth dongle. That is taking control of that dongle, and that is running the drone ID, not to confuse with DJI's, but that is control Viper. Viper, trying to think of his whole Twitter name. Sorry if I'm messing it up, but the individual from Twitter who, um, you know, kind of speaking back and forth with him, and really helped out putting together a really nice repository for drone ID using sniffle based firmware, and that's what I'm using there to leverage that open source code and the decoding of the Bluetooth type remote ID. And then what else? The ZMQ decoder service is running, and what that's doing is that's taking the information from the Bluetooth dongle. Now, I should point out there is a way to use a Wi-Fi internal card in order to cover Wi-Fi type, but I chose not to do that yet, at least on the WarDragon. Well, one, the card is internal Wi-Fi card, so that's not going to get a lot of distance. And maybe in the future I'll look at adding an external card, but I'm not using that particular feature of the Drone ID repo. I chose to dedicate an ESP32 and kind of come up with my own solution to get me detections and decoding of Wi-Fi based remote ID. So, anyways, that ZMQ decoder service, it is looking at the port, the ZMQ. There's multi levels of ZMQ here. So the ZMQ decoder is looking at the ZMQ server that the sniff receiver is offering up. So there's info, Bluetooth related info coming off of the sniff receiver service. The ZMQ decoder looks at that port. It could also look at the Wi-Fi port, but I have not enabled that. So anyways, it sucks in the Bluetooth information and then decodes it and then spits back out on port 4224 any Bluetooth remote ID decoded information. Now, what I did was I had asked the author to please include accommodations for what I did, which is the ESP32 mod. So a ZMQ decoder can also be told at the command line to connect to UART on whatever port. And so in the case of the WarDragon, I have sim linked and I have created ports so that this all works nicely together. And it's looking at the dev ESP0, okay, and it's just sucking in that ESP32 created information, and by essentially just passing it right out the ZMQ other side of the ZMQ server on port 4224. Probably should do a block diagram on this, but just know that ZMQ decoder is taking information from the Bluetooth dongle and the ESP32, and it offers it up on 4224. All right. Let's see. Now, the DragonSync repository I referred to, just to show you an example here, and I'm going to just make it to where I don't really have to worry about GPS for right now. I'm sure you can probably know what's up there. This is all in a protected little box here, but still, I didn't want no GPS on my Bluetooth drone remote ID receiver. So I'm just going to show a very simple, let me see, Python 3, DragonSync. Lots of options to this DragonSync repository that I had put together here. I guess I should probably point out too, if you're following along, this screen that you see here, this is me, Rustdesk, connected to a remote WarDragon. So that's how I'm administering this right now. Okay, so if we look, there's a lot of options here. I have it defaulted where it'll just do multicast information. And so, yeah, so I'm seeing that a drone is detected, but there is no GPS right now. I am doing that on purpose. There is also information every so often, which I'm just going to minimize this because we don't need that scene right now. There's also every, what is it, every 30 seconds I think I have it defaulted that a status message goes out about the WarDragon itself. And so that information would pop up multicast on an ATAK map and show where the WarDragon is, or where the drones are that are being detected. And what I'm going to do is, because I have a little more control over Wi-Fi type, let's see what we got here. Let me clear this screen so there's just no GPS information. So what I'm going to do is I'm going to spoof, and we can stop the whole GPS sim here. Then we can kind of see a little bit more of what's going on here. So now we've got full-on Wi-Fi based drone remote ID. Let's take a look. Let me see. Let me see if I can do this here. Let me change this to multicast. So now I'm going to jump into the app. Let's do one more thing here. Currently, I need to do ATAK multicast ADR 224.0.0.1. Do that. I'm going to leave the debug off. So it's sending messages, multicast. Let's see. So I got multicast. So this is our app over here on the iPhone, and you can see. There we go, iPhone. And this is being created by an individual. Luke, I think, goes by. I'm sorry, I get making a video and then I forget a lot of things. Let's see. I'm going to change this to active. And there we go. So we have that drone that I am creating basically here. I'm doing multicast, so I'm just showing the app taken in multicast. And let's do a little live thing here. And of course, this isn't a real location, but you get the idea here. So, and now if I go over to status, which I don't really want to do because I don't know if I have it set up where I have a GPS lock on the WarDragon, and we don't need to be known exactly where that WarDragon is. But if I clicked on status, you're going to see all the WarDragon information. And had I had thought this out a little bit better, because I think that's doing a disservice not showing that, you do see where the WarDragon is. You see information. Actually, you know what? Let's just see. What I'll do is I'll blank out the GPS location, but you can kind of get an idea there. You can see at least one of the systems is up. You can click on it to get more information, memory details in this case, about the actual system itself. So, all right, let me click off of here. And so that is the multicast way of getting information into the iOS app that is being designed for the WarDragon. Obviously, you could also run ATAK. You can set up, I've shown it in previous videos, you can get really sophisticated and set up a ATAK server. Well, it's not that sophisticated, you know what I mean? It's not too terribly difficult to do that, but you can set up a ATAK server. So you could have multiple WarDragons out there monitoring for drones, and you're going to get this situational awareness of what's going on all in real time back at a ATAK server. If you have your other client devices connect to it, they will in turn see the most updated information as to where the WarDragons are at, how they're doing, the actual drones themselves. Excuse me. And in ATAK, there is a lot of information that is shown in the remarks, because it can't all be shown on the map per se. So just know that that's there. Now, if I take a step back and instead of doing multicast, I stop this and I connect it direct to the ZMQ. And let's look at the Sorry, I just cleaned it up. We don't need to be seeing all the MAC addresses, but I was just looking at the IP of the WarDragon. I wanted to get that. That is actually 190. So let's change that to 190, and we'll connect direct to ZMQ. Let me delete this, and you can see that it is coming back. It is pulling it in from the ZMQ server, and it's updating that information. So we're getting it both via direct ZMQ. I don't know if for some reason you had boxes remotely and you didn't have a setup where multicast was able to cross across maybe a VPN or something like that. You could go, TCP or well, basically a direct connection remotely to the box. Now, of course, you have to have some way of reaching the box, preferably a secure VPN of sorts. But I'll leave that on the users that are setting this up. So I know that maybe not as exciting as seeing drones flying around, but I really wanted to walk through and just give you my concept, my ideas on how the WarDragon Pro would work out of the box. Now, the WarDragon Plus that is currently out there with the Air Spy in it, it does have the ones that are more recent have the Bluetooth dongle, and so I have started up a service on them that, much like what I've shown you here in this video. I just didn't activate the ESP 230 side of things. So it can still detect Bluetooth drones, and the Dragon Sync repo would work, the app would work. I'm just trying to build up things around the Pro with more capability, more drone, based detection capability. And, of course, the UHD can do many different things, or sorry, the ANTSDR can do many different things. It's compatible with Open Wi-Fi. A lot of your cellular type tools work with it. Uh, a Pluto-based firmware can run on it. I mean, it's just a crazy amount of things that you'll be able to do with that SDR. I'm just kind of hoping to uh, tailor it to the drone detection, and my hope is to have that video link detection on there as well, in addition to all the other capabilities that already exist for it. All right, so let me know if I missed something, if I went too fast. Just ask questions in the comments section, and let me know what else I need to touch on. All right, thanks for hanging with me, and stay safe out there. Look for these WarDragon Pros to be available soon, and hopefully it helps out. All right, thanks.